Good morning everyone. Today we are going to start with next topic of our chapter number 3, that is pulleys. Okay. First we will understand what is a pulley. Basically this is the diagram of pulley. This center part that is known as frame. In fixed pulleys that frame that remains fixed. Okay. And then this part around which the pulley rotates, this is known as axle. Axle, I believe all of you understand, whenever a circular part is moving around a fixed point, that straight bar which is passing from that circular part, that is working as its axle. This pulley is sometimes maybe made up of plastic or sometimes it is made up of a metallic. Actually this is disc in shape. So this is metallic disc, this outer part that consists of your pulley. This metallic disc has grooved edges. Grooved edges का मतलब थोड़ी सी उठी हुई edges, मतलब बाहर की तरफ ऐसे थोड़ी उठी हुई. Let me show you if I will get that. Just hold on. I hope you are able to understand it with the help of this. This part, this is acting as metallic or plastic disc. These two parts which are little bit edged, so these are the grooves of the pulley, and this part, this is acting as axle. When you will just stretch the rope, it will start moving along its axle. ये देखो axle के around move करती है. So this is how pulley works. These two lines which are representing a straight line, that makes the axle. ये इसका axle होगा around which the pulley moves. Okay, and this is the center part. These two are known as grooved edges. I believe I made my point very clear to each one of you. Now let us talk about little bit all the key points of a pulley. First one, this is a metallic disc with the grooved rim. Okay, and a string or rope winds around the disc. Disc के बाहर आपको एक string या rope बाहर घुमाना होता है. Okay, disc rotates about an axle passing through its center. This is all about how we can define a pulley. Okay, now when we are talking about this topic pulley, when this pulley can work as single individual pulley, it can work as combination of pulleys depending on our requirement, whether we need pulley just to change the direction of the force applied, or we need it to multiply the force. Depending on that, we are using it as single pulley, single fixed pulley, single movable pulley, or we are using it as combination of pulleys. So when we are talking about single or combination of pulleys in a rim, that complete setup, whether we are talking about a single pulley as I have drawn over here, or if I am drawing more than one pulley over here, मैं इसको extend करूँ, यहाँ एक और बना दूँ, that seems little bit like this, कि I am drawing a larger frame over here and I am drawing two pulleys over here this way. So two pulleys are in a single frame. So this complete consists of a block. This complete is known as block. Okay, this complete is known as block. So single or combination of pulleys in a rim, that is known as block. Maybe single pulley, maybe two pulleys, maybe three, maybe four, maybe five, whatever number is there in single frame, that is known as block. Okay, rope that winds over the pulley, whatever rope we are using to wind over the pulleys, that rope is known as tackle. So sometimes in few of the books, in your book too, they have given a name, that is block and tackle system. So what block means over there? Block means number of pulleys in one frame. Okay, maybe that is on the upper side, maybe that is on the lower side of the system. Number of pulleys in one frame, that consists of block. Okay, tackle is the rope which is wind around the pulleys, that consists of tackle. Okay, now in this chapter, let us start with studying single pulley. How single pulley can be used? Single pulley can be used in two ways. One, it is used as fixed pulley. Second, it is used as movable pulley. Now what is the basic difference between fixed pulley and movable pulley? Fixed pulley is that which has its axis of rotation fixed, like this way. When we are talking about this pulley, so if I will just wind a rope around it this way and I'll start stretching the rope from here and tie some load over here, so this pulley will keep on rotating at this place only around the axle. So this axis of rotation, that remains fixed. So this fixed pulley has its axis of rotation fixed. What about movable pulley? In movable pulley, we are not keeping this frame fixed. Okay, what we are drawing there is, we can draw movable pulley this way. Suppose this is a rigid support. Okay, we are tying a rope over here and this rope we are using to hold a pulley. Okay, this pulley is not fixed. So whenever I will just apply force in this direction, along with the load, this pulley will also start moving in upward direction. It will start moving along its axis, ये ऐसे भी घूम रही है, ऐसे ऐसे घूमती है, but साथ साथ it will keep on moving in upward direction. So its axis of rotation that will not remain fixed. ये एक जगह पर नहीं घूमेगी, ये घूमे 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 साथ में ऊपर भी जाएगी. That means the axis of rotation that will not remain fixed, and this is what we are talking about as movable pulley. Now what we have to do further in the chapter is we need to study about this fixed pulley, single movable pulley in detail. Where can we use it, means what is their mechanical advantage, whether they are used to just change the direction, or they can be used as force multiplier, speed multiplier, or can they be used together, that we need to study further. So let us start with the first one, that is single fixed pulley. How the single fixed pulley can be used, what will be the mechanical advantage of this single fixed pulley. Let us talk about that. Now we will start with single fixed pulley. This is the diagram of single fixed pulley. I have drawn it. This is the pulley, the frame of the pulley that remains fixed with the rigid support, and this is the load which we are handling with the help of this pulley. So I tied load over here, and on the other side we are going to apply the effort. So whenever we are studying about pulleys, we need to draw few of the things, and we need to take care while drawing few of these things. First thing, the rope which you are drawing, that should be drawn straight one. उसके अंदर bent कम से कम दिखाइएगा. That if you will show bent, that means there is loss of energy. तो bent नहीं दिखाएं, please make it straight. Okay. Then what you need to do is you need to draw the direction of the force applied. The direction, load is a type of force. We studied it. Load is a resistive force which we need to overcome, or which machine has to overcome. So this is load. So what is the direction of the load? Load is in the downward direction, because the weight of the load, that is equal to m into g, that is exerted into downward direction. So the direction of load, that is in downward direction, so mark it as L. So load is in downward direction. When we are hanging load over here, so due to this load, there is a tension in the string. Because of this, the tension in the string is created. So this tension is in opposite direction to that of load. हमेशा आपको पता है tension एक opposite direction में हम create मानते हैं अभी तक. So this is represented by capital T. So this is the tension which is created to balance the load. To balance this load, a tension is created in the string. So this tension is shown this way over here. Okay, here we are applying the effort. When we are applying the effort in this direction, we are going to pull it this way. When we are going to apply the effort in downward direction, again there will be a stretch or a tension which is used to balance this effort, that is tension over here. So one tension you are going to mark here, and one tension you are going to mark here. Okay, now we need to find out the mechanical advantage of this pulley. That means for what purpose we can use it. We can use it as force multiplier, speed multiplier, or just to change the direction. That we can find out with the value of mechanical advantage. So let us find out that. From here you are aware load is balanced by one tension, effort is also balanced by one tension. And mechanical advantage, we people are aware, that is equal to ratio of load upon effort. So in place of L or T, I can place the value TT over here, this T by T. So that will be cancelled out, is equal to 1. That means mechanical advantage of a single fixed pulley is 1. When mechanical advantage is 1, so we are aware that we can use it to change direction. This is used to change the direction of force applied, direction of effort. Okay, we can apply the effort in convenient direction as desired by us. Okay, then we are coming on to the velocity ratio. How to find out velocity ratio? Velocity ratio is the displacement of effort to the displacement of load. Now in this situation, whatever you are going to displace effort, जितना आप इस rope को नीचे लेकर आएंगे उतना ही आपका load ऊपर चलता जाएगा. Suppose this is the load over here. Effort आपने यहाँ लगाया, जितना आप effort को नीचे खींच रहे हैं, load आपका ऊपर जाता जा रहा है. So if D is the displacement shown by the effort, so same is the displacement shown by the load. So this velocity ratio will be D upon D, that will be equal to 1. So velocity ratio is also 1. One more thing you need to remember is whenever we are talking about any kind of machine, whenever we are designing the machine, making the machine, at the same time the velocity ratio of the machine that gets fixed, that will not be affected because of the friction, because of the rigid parts. किसी भी वजह से आपका velocity ratio effect नहीं होता. The value of velocity ratio is not going to change. कोई भी situation हो, mechanical advantage can change. वो चेंज हो सकता है डिपेंडिंग ऑन द वैल्यू ऑफ, डिपेंडिंग ऑन द टेंशंस अप्लाइड ओवर देयर, बट आपका जो वेलोसिटी रेशो है दैट विल रिमेन सेम. सो इफ वी आर टॉकिंग अबाउट सिंगल फिक्स्ड पुली, हर बार सिंगल फिक्स्ड पुली के लिए वेलोसिटी रेशो आपका 1 रहेगा. मैकेनिकल एडवांटेज आपका चेंज हो सकता है. सपोज दे हैव गिवन यू द वैल्यूज, यहाँ 400 है और यहाँ 200 है. सो व्हेन यू आर गोइंग टू डिवाइड इट, यू आर गोइंग टू गेट 2. सो मैकेनिकल एडवांटेज कैन बी 2. यहाँ आपका 200 है, यहाँ 4 है, दैट विल बी 1/2, बट वेलोसिटी रेशो विल ऑलवेज be 1. वो आपका 1 ही रहेगा. And second thing, when you are taking one single string, the tension throughout the string will remain same, that is T. चाहे वो कितनी भी जगह आपको बनानी पड़ेगी, if you are using one string, you are going to mark same tension at all the points wherever you are marking. If you are taking more than one string, अगर आप कोई सिस्टम ऐसा बना रहे हैं जिसमें आपका एक से ज्यादा स्ट्रिंग यूज हो रहा है, then depending on number of strings, number of tensions you are going to mark. If 3 strings are there, 3 types of tension will be there. If 4 strings are there, 4 type of tensions will be there. But here we are talking about one string, so हर जगह पर T same value will remain there. Okay, now coming on to efficiency. Efficiency, how can we find out? Efficiency is equal to velocity ratio upon mechanical advantage upon velocity ratio. So when we are talking about mechanical advantage 1, velocity ratio 1, so that will be equal to 1. That means efficiency is 100%, because we are considering this is ideal pulley. हम उसके अंदर फ्रिक्शन या कुछ भी मान नहीं रहे हैं, तो वी आर अज्यूमिंग इट एज आइडियल पुली. सो आई होप ऑल ऑफ यू अंडरस्टैंड हाउ टू फाइंड आउट मैकेनिकल एडवांटेज, वेलोसिटी रेशियो एंड एफिशिएंसी फॉर सिंगल फिक्स्ड पुली. Okay, now coming on to single movable pulley, how to work for that. Again, this is the load. The load is acting in downward direction. Load is acting in downward direction. Just show it this way. This is acting as load. Okay, when load is acting over here, the tension is created both the sides. जब आप अब यहाँ पर load hang करते हो तो यहाँ भी खींचता है, यहाँ भी खींचता है. So this load is balanced by these 2 tensions. Here it is balanced by only 1. Okay, because stretch is created over here only, but when you are hanging load here with the movable pulley, the tension is created in both the strings. These are the 2 tensions which are balancing the load. So load will be balanced by 2 tension. You can write it this way. Okay, this is effort here at this place. मैं इसको ऐसे खींचूंगी ऊपर की तरफ. So effort is applied over here. This is the effort. And to balance the effort, one tension is created over here. ये tension effort को balance कर रहा है, ये tension आपके load को balance कर रहा है. Fine. So effort is balanced by one tension. Okay, so how to find out mechanical advantage? Mechanical advantage is equal to load upon effort. That will be equal to, load is 2T, effort is single T, that will be equal to 2. Means mechanical advantage for single movable pulley is 2. That means it can be used as force multiplier. Not only to change the direction, we can use the pulleys to multiply the force. By applying less amount of force, we can lift a larger load. Okay, here this can be used as force multiplier. What is the velocity ratio? Velocity ratio, again, just listen to me. You need to understand it very carefully. When you will stretch it from here, आप इस रस्सी को यहाँ से ऊपर से खींचते हो. Suppose it is covering distance D. ये D distance ऊपर आ गई. ये D कहाँ से आया? थोड़ा सा रस्सी यहाँ से गया, थोड़ा सा रस्सी यहाँ से मिल गया, दोनों मिलकर यहाँ आपका बाहर निकल गए. आपने यहाँ से खींचना शुरू किया, थोड़ा ये यहाँ से बढ़ी और थोड़ा ये यहाँ से होकर ऊपर आई. So this is D/2 and this is D/2. ये दोनों, ये D/2 और ये D/2 यहाँ ऊपर निकल कर आया as D. That means displacement of effort is D. And what will be the displacement of load here? This load, ये load आपका कहां तक चला जाएगा? आपकी पुली ये ऐसे ऐसे ऊपर मूव करेगी and load will come over here. आपका लोड यहां ऊपर आ जाएगा. So how much this load goes? ये इतना ऊपर चले गया बेटा, आपका यहां से लेकर यहां तक ऊपर गया. So this is the distance which is traveled by load. That is d by 2. That is equal to d by 2. जितना भी आपने पुली का यहां से स्ट्रेच किया, d आपका डिस्टेंस एफर्ट का गया है, तो लोड आपका कितना जा रहा है? d बाई 2. हाफ लोड उसका ऊपर उठ रहा है, क्योंकि ये पुली देखो बेटा यहां से मूव करेगी, ऐसे ऊपर जाएगी. ठीक है, यहां से जितना भी खिंचा है 2 सेंटीमीटर, 4 सेंटीमीटर, 6 सेंटीमीटर, सपोज 6 है, तो लोड कितना ही ऊपर आया? उसमें से 3 यहां से निकल गया, 3 यहां से निकल गया, टोटल 6 आपको यहां ऊपर दिखता है. वो रस्सी 6 सेंटीमीटर ऊपर चले गई, बट लोड कितना आया? यहां से 3 गया ना, तो ये 3 ही ऊपर उठ रहा है लोड. सो लोड इज ट्रेवलिंग हाफ द डिस्टेंस. ओके, जितना भी आपका लोड है वो उसका हाफ डिस्टेंस ट्रेवल कर रहा है. सो डिस्टेंस ट्रेवल्ड बाय लोड इज d by 2. सो वेलोसिटी रेशियो इज de upon dl is equal to d upon d by 2. So you can say this is again 2. So velocity ratio is 2. Similar way you can find out efficiency, that is mechanical advantage upon velocity ratio is equal to 2 by 2, that is equal to 1, means 100%, because we are assuming that this pulley is ideal pulley. Okay. Now this pulley can be used as force multiplier. This pulley is used to change the direction. So single pulley can be used in 2 different ways depending on how are we using it. If we are using it as single fixed pulley, this is used to change the direction. If we are using it as single movable pulley, this is used to multiply the force. So what are the basic differences between single fixed pulley and single movable pulley? Let us talk about those differences. The first one is it has fixed axis of rotation, it has movable axis of rotation. Its mechanical advantage is 1, its mechanical advantage is 2. Its velocity ratio is 1, its velocity ratio is 2. It is used to change in direction of effort, it is used to multiply the force. Okay, what else? In this one, the effort and load both are moving in the different direction. Just see, effort is coming in downward direction, load is moving in upward direction. So effort and load both are moving in different direction. But in this one, the effort is moving in upward direction और load को भी ये ऊपर उठा कर लेकर जा रहा है. So both load and effort, they are moving in same direction in case of single movable pulley. But in case of single fixed pulley, both are moving in different direction. One more is there. It is the weight of the pulley itself. As this has fixed axis of rotation, so weight of the pulley is not going to affect the mechanical advantage, because only this weight is creating tension over here. Okay, this load is creating tension over here. But in this case, load plus the weight of the pulley, if pulley is not considered as weightless, so the weight of the pulley is also to be raised with the help of the effort applied. हमें effort सिर्फ इस load के लिए नहीं लगाना, ये pulley भी तो इसके ऊपर अपने आप का weight exert किए हुए है. So the weight of the pulley is going to affect mechanical advantage of the pulley. Okay, means that may be changed to a force multiplier, that may be changed to something else. Now what we need to understand is, see, this is used to change in direction, this is used as force multiplier. But जो आपका change in direction है वो सिर्फ change in direction का काम कर रहा है. We cannot use it as force multiplier और हमारे कोई काम का नहीं. Okay, in this one it can be used as force multiplier, but in this we are not able to apply effort in convenient direction. What if we are going to combine these two? अगर हम इन दोनों को combine कर दें and we make an arrangement, then what will be the benefit? Let's see that also. This is how we can use the combination of single fixed pulley and single movable pulley. This is our movable pulley. With the help of this we are tying our load. This is our fixed pulley. This is able to rotate about its fixed axis of rotation, and this is where we are going to apply the effort. Due to this load which is acting in downward direction, this is load, there creates two tensions. This load is balanced by these two tensions. One is here, one is here. Again I am repeating, we are using the same rope. We are using one single rope. That means tension will remain same at all the points. Okay, so this load is balanced by these two tensions. This is the effort which we are applying over here. This effort is balanced by this tension which is created over here. Then what we need to do is, we need to find out mechanical advantage for this. Let us find out mechanical advantage is given by load upon effort. What is load? Load is balanced by two tensions. So load is equal to 2T. So I can write down 2T over here. Effort is balanced by one tension. This is single T. So I can write T over here. Okay. This T will be cancelled out with this. Mechanical advantage will come out to be 2. Okay. Similar way, velocity ratio. Velocity ratio is displacement by effort. This effort, suppose it is covering D distance. ये यहाँ D तक नीचे आ गया आपका. So how much it is lifting up the load? D by 2 from here, D by 2 from here. D by 2 यहाँ से निकल के आया, D by 2 यहाँ से निकल कर आया. इतना टोटल रस्सी यहाँ पर बढ़ गया आपका. Okay, so this is the displacement by effort. Displacement by effort I am saying as D. So displacement of load, ये कितना ऊपर जाएगा? यहाँ से यहाँ तक जा रहा है. Only this much. That is D by 2. It will go D by 2. So similar way, displacement of effort upon displacement of load. That is equal to D upon D by 2. That gives you 2. So velocity ratio will be 2. Now you will say, ma'am, what will be the benefit of this? Because mechanical advantage is 2. This is used as force multiplier. Yes, it is used as force multiplier. But see, in this arrangement, you are going to apply the effort in your desired direction. Okay, in downward direction, which is easy for you to apply. Okay, this is what we want. We want this works as force multiplier, as well as we can apply force in our convenient direction. And here we are applying the force in our convenient direction. Means this combination is working as both to multiply the force, because mechanical advantage is 2, and to change the direction. This is what I explained you. A machine can be a force multiplier and to change the direction, or it can be a speed multiplier or to change the direction, but not both speed and force multiplier. This is not both speed and force multiplier. This is only force multiplier, and it is used to change the direction. Okay, so this is how we can use combination of pulleys for different purpose. Okay, so now what you are supposed to do is, you have to read out this topic from your book, and in next video we are going to discuss about more combination of pulleys, that is your block and tackle system. Meanwhile, read out from the book and do the related questions from this. Okay.